And it's fun, but it's costly. And then there are short-term costs of implementing new rules, figuring out what they are, and then the long-term costs of monitoring and maintaining a self-governing system over time. So those are variables we've identified, and if you want to sum this, we just don't worry about it. I'll just go out and cut it all and look at it. If all or a winning coalition agree to adopt new rules, they will move on. But they may stay with what they have. That depends on the perception of benefits. Their perception of benefits may not be fully accurate, but it's the perception of benefits that people have that affect whether or not they think that it's worthwhile changing their rules. And if there's some variance in benefits and costs are perceived, it depends upon who's in a winning coalition for that particular problem. And that may be a majority rule, or it may be a lead capture, it could be any of a wide variety of things. Now, the problem that we have is that we can't get inside everybody's head who is facing such a situation and then measure the perceived benefits and costs. So this theory is beautiful. It's predicted beautiful equations and all the rest, but it's very hard to test in the field. So what we've been doing is linking that broad theory back to the framework, and to use the framework then to identify a variety of variables that are second-tier variables, in terms of two that relate to the resource system, one that relates to resource units, five that are dealing with the actors, and two that deal with governance system. These are potentially relevant, so if you're looking at self-organization, you would want to be including those variables in the meta form that you were going to use. And so what we've done is we've started well, not on this one, sorry. On an earlier slide, we had those variables all started that I mentioned, and we've been slowly but surely using them in a wide variety of ways of looking at when do people self-organize or not. So the size of the resource system, when it's sufficiently small, given communication and transportation technologies, users can acquire pretty accurate information about what is going on. When the system is highly productive and it's not been exhausted already, it's worthwhile doing work in the future. If it's already exhausted, forget it, go on to something else. And whether the system is predictable, it makes a big difference in your being able to estimate those sorts of things. In terms of resource unit mobility, we found that fisheries and water systems that go on where the resource units move are much more difficult to organize than collective action problems around stable resources. Forestry turns out to be easier, even though it's difficult, but it's easier because of the trees for food, unless you deforest them, but that you take them away. The number of actors, the researchers have found a non-linear relationship between the number of actors and self-organization. Small groups are frequently unable to undertake costly activities, while transaction costs are higher for large groups. So you've got these two things against one another. So the impact of a number of actors on self-organization depends on its relationship to the size of the resources. So if the resource system is huge and the number of groups of individuals is small, it's hard. You need a large size to organize a large resource unit. The amount of leadership and entrepreneurship that people have found in the field that is associated with successful self-organization is high. And so trying to find out what kind of leaders there are, and their entrepreneurial skills are very, very important. The norms in social capital, we have talked about repeatedly as being very, very important. If people share them and trust one another, they are much more likely to solve these problems. And their knowledge of each other is what kind of mental models are they using about this SES. Do they understand it? So people moved to a biodiverse area recently have a much more difficult time figuring these things out than people who've been there for a very long time. And then the importance of the resource to the actors. Are they dependent on it? Or do they just attach a high value? Sometimes seeming aspects of the resource system are very important. And then the collective choice rules that are in force. Do the harvesters have autonomy to make some of their own rules? So not one of these variables is always positive or always negative. We're finding them very consistently involved in the set of variables affecting the likelihood, but they are not a sort of thing that every time the group is dependent on, or it can be small, etc. So it really is this notion of context. And we need to be looking at the aspect of this resource system and the ecological context and the social context. What we've been able to do is look in the fields. There'll be in the Ecology and Society special issue, there'll be about 8 reports on studies using this. If anyone here is interested in inshore fisheries, Hilburn and his graduate students at the University of Washington got very interested in the framework and have used it now for quoting a very large end of inshore fisheries and find it very helpful. They find, for example, that leadership is very important, but they find that it takes about 8 variables to really be consistently predicting across a large end. Leadership is in that set, but it is not just one variable. One of the findings that we have repeatedly is the importance of local monitoring. We're finding that it is very important in terms of improved local conditions. We can go back to early studies that have been done showing that, and now 3 recent studies by Eric Coleman in Journal of Policy Analysis Management, Coleman and Seed in Ecological Economics, and Chatray Agrawal in PNAS. So there's a lot of support now for local monitoring. Now we are working with colleagues here in Mexico and other parts of the world. We have many variables. Part of the evolution of the SES framework came from our effort to try to identify variables relevant when we were doing field work. This right to harvest from the forest turns out to be a very important variable that leads to people being willing to monitor. And again, out in the literature, the idea that people having a right to harvest is not as much identified as it needs to be. But if people have long-term rights, they may not be able to timber, but if they have long-term rights to some attributes of a forest, then they are more likely to monitor. And if they're more likely to monitor, the forest is likely to be in better shape. So keeping local users out of forests is not a panacea. So we're working with a large number of colleagues around the world in terms of developing a clear set of definitions of the key terms that I just showed you. We're beginning to develop some dynamic models of how these fit together and put it to diverse puzzles. It's not just all clear, but we're working on it. We welcome others who are willing to work with us on it. We're planning to do more studies of social ecological systems over time. Fortunately, IFRI has already done some over time, but we hope that we're able to find ways of doing some more. And then we can find which propositions hold in regard to different social ecological systems at diverse states. So we have lots of work for the future, but if we work together on this sort of thing, we can slowly but surely help solve problems that have been at the forefront.